Sigma and pi bonds. So molecular orbitals. When two atoms combined, this model assumes that their atomic orbitals overlap to produce molecular orbitals, or orbitals that apply to the entire molecule. In some ways, atomic orbitals and molecular orbitals are similar. Just as an atomic orbital belongs to a particular atom, a molecular orbital belongs to a molecule as a whole. A molecular orbital that can be occupied by two electrons of a covalent bond is called a bonding orbital. So, sigma bonds. When two atomic orbitals combine to form a molecular orbital that is symmetrical around the axes connecting the atomic nuclei, a sigma bond is formed. So, sigma bond, first off, the symbol is the Greek letter sigma. When I draw my sigma bonds, it's basically just like a, oops, sorry about that, don't worry about that, an O with a tail, basically. So we see here the s atomic orbital. Remember, s orbitals have a spherical shape, okay, and they produce the sigma bonding molecular orbital. And we see the bond axes right through the middle. And the positive charge represents the nucleus, right? Sigma bonds are single bonds. Okay, to count sigma bonds, just count the number of single bonds in your Lewis structure. So, for example, it says how many sigma bonds are in methane. Methane we know is CH4. So if we did that, carbon with 4 single bonds around it. So since there's 4 single bonds, we have 4 sigma bonds. Now, pi bonds, as shown here, the side-by-side overlap of p atomic orbitals, which we know are dumbbell-shaped, produces what are called pi molecular orbitals. Okay, so we see the p atomic orbitals and then the p bonding molecular orbital. In the pi bond, symbolized by the Greek letter pi, which we know about, the bonding electrons are most likely to be found in a sausage-shaped region above and below the bond axes of the bonded atoms. And pi bonds are double and triple bonds. So pi bonds, so a double bond is equal to 1 sigma and 1 pi bond. So an example of that, say we had C2H4. We have 12 electrons. 12. So now if we want to count sigma bonds here, so we count them. So we have 1, 2, 3, 4, 5. So 5 sigma bonds and our 1 pi bond. Now a triple bond, we have 1 sigma and 2 pi bonds. So if we want to count the sigma bonds, we have 1, 2, 3. So 3 sigma. In every triple bond, we have 2 pi bonds. So we have 2 pi bonds. And this concludes our video on sigma and pi bonds.